Hi everyone, my name is Ziyi. I'm currently a PhD student at University of Illinois, Urbana-Champaign. Today I will present our paper. Its name is CrowdGraph, a crowdsourcing multi-modal knowledge graph approach to explainable Fauxtography detection. So firstly, what is the Fauxtography post? A Fauxtography post usually consists of an image and a text description. There could be some misinformation in it. The misinformation may originate from the image, the text, or the association between them. In this paper, we mainly focus on the human-centric Fauxtography post. That means there are some human faces or human entities existing in the post. We show some examples below. For figure A, it is a non-Fauxtography post. That means there is no misinformation in any component of this post. But for figure B, C, and D, there are some misinformation. They could exist in the text, the image, or association between them. In previous research, there are usually three different ways to do the Fauxtography detection. The first one is the binary classification. It just encodes the text and the image to high-dimensional embeddings, and then uses embeddings to do the binary classification. It can detect Fauxtography, but it cannot explain why this post is Fauxtography or not. The second one is the binary classification with attention. So attention can help model to retrieve the most important or relevant words or image regions from the multimodal posts. But it can help researchers to know why the models make such a decision. But for common people, they have zero professional knowledge, and they still don't understand why this post is true or not. The final one is the knowledge graph-based classification. So in this one, there is the existing or constructed knowledge graph that contains the semantic entities and their relations in this domain. And a model can retrieve the relevant knowledge from this graph and use this knowledge to infer if this post is true or not. And after inference, the retrieved knowledge facts can be the explanations. We can say the knowledge graph can really help the model to explain why a post is true or not. So we also want to have such a knowledge graph to detect the human-centric Fauxtography post. But two challenges exist here. The first one is the dynamicity of implicit knowledge graph relation. We know that the relation between humans are complex, especially for some famous peoples. The public may know some stories or experience, but they can't say it in the official document. So there's no authorized knowledge graph for us to use. The second one is the dynamicity of the human relations. For example, the death of Prince Philip's is a Fauxtography before 2020, but it is true after 2021. That's also a challenge. We know that Fauxtography post is multimodal, and but also the knowledge graph could also be multimodal because the knowledge graph can contain the human-related entities and also the human faces or human-related images. So how to collaboratively merge these two multimodal information to identify and explain the inside Fauxtography content is also a challenge. To solve the above challenges, we propose the CrowdGraph. So the goal of CrowdGraph has two. First one is to detect Fauxtography posts, and the second one is to provide reasonable explanations. We show the overall figure or structure of CrowdGraph here, and we'll talk about it one by one. We firstly create a module to task online crowd workers to create a multimodal knowledge graph. There are two interfaces. The first one asks crowd workers to identify the relationship between different entities in each post. The second one is asking crowd workers to identify the relationship between the humans across different posts. After collecting responses from these crowd workers, we model the responses as a multimodal knowledge graph, where the input are modeled as graph entities and the relations are modeled as graph edges. Second module is about the Fauxtography post. So for each Fauxtography, we want to embed it to a high-dimensional feature to integrate it with the knowledge graph in the following steps. So we have three different components. The first component encodes the text entities to high-dimensional embeddings by using a bidirectional GRU network. The second one will firstly detect the human faces from the image, and then use a co-attention module to explore the correlation between each human face and each text entity. Finally, we use the ResNet to extract the global feature from the image because we don't want to lose any visual information. Finally, we merge all of them together to get a single feature for each post. The third module is about how to integrate the Fauxtography post and the knowledge graph. We firstly do the graph convolution on the global knowledge graph to explore the multi-hop relations between different graph entities. And then we use the feature of the Fauxtography post as a guidance and merge the feature with the subset of knowledge graph. The subset contains the relevance of the same text entities and image objects compared to the Fauxtography post. Finally, we convert the subset graph to a set of knowledge facts. Each knowledge fact will be computed attention score. Finally, all the knowledge facts will be integrated together to get a single feature for this Fauxtography post. The final module is about detection. So we want to use the generated single feature to do the binary classification to optimize the feature extractors and also the knowledge graph. To solve the problem from the dynamic human relations, we periodically extract the knowledge facts with top attention scores and the bottom attention scores from the knowledge graph and to ask the crowd worker to recheck it again. If there is anything changed, we will change the knowledge graph accordingly. We have two datasets for our experiments. The first one is extracted from the fake Reddit and the fake Newsnet datasets. We only search for the human-centric post. And to test the generability of our model, we also ask the crowd worker to create a new small dataset by submitting the Fauxtography post they found in social media. We firstly evaluate the Fauxtography detection accuracy of CrowdGraph. We can see CrowdGraph outperform all other baselines in Table 2. It demonstrates that the crowdsourcing answers from both interfaces can recognize both texture and visual information of posts. And in Table 3, we further generalize that our model is extended to address unseen Fauxtography posts. Our CrowdGraph can also outperform all other models. We further evaluate the explainability of our model. For each model, we extract the top K knowledge facts from knowledge graph based on the attention score as the explanation results. And we ask CrowdWorker to select which result is the best. We can see from both post level and worker level, our results outperform our other baselines. That's it. Thank you.